Right? We would like to know the slope of the graph at every point, even though it's changing its slope at every point. This particular picture, we're trying to find the slope here, right at that point. And we do it by using 2 points on the graph, drawing a line. That's not a tangent line. Do you remember what do you call a line which intersects in two places? You did this in geometry, secant. Right? That's a secant. So we could take 2 points on there and we calculate the slope. Will that be exactly the slope of a tangent line through that point? No, won't be very good. If I let the distance between the 2 points get smaller, which means this h here is getting smaller, as the points come together, maybe the slope will get a little bit better approximation, right? And I can let it get even smaller, get the points even closer. We might see a trend in the numbers that it looks like they're approaching some fixed number. But can we ever let those 2 points come together? Can you take the slope with just 1 point? No. If you use the same point for x1, y1, and x2, y2, then you're dividing by 0. I mean, you actually get the indeterminate form, 0 over 0. You can't do that. So we're not going to be able to do that, but what we could do is find the limit of that process, which means we're going to let those points get infinitely close, but not quite touch, right? And in that regard, we'll see what was that value it looks like it was approaching, and that will be the value of the slope at that point. So this is how we did it, right? M equals, and this is the y2 minus y1 over x2 minus x1. It's just the x2 is x plus h, right? And the x1 is x. So when you subtract, you just get the h. H is the difference here. Right? That's the difference quotient.